In this lesson, we're looking at product rule for counting for the further maths specification. So these type of questions will not be in GCSE, they'll only be in further maths, but it is an extension of the GCSE work. So thinking about what we did last lesson, we learnt that when we are arranging items into specific positions, the order that they are in matters, therefore we don't divide as we don't get duplicates. However, when we're selecting items, order doesn't matter, that's when we need to divide to remove duplicates. So let's have a look at this example. How many ways can the letters of the word April be arranged? So here we're arranging the letters, so order matters, so we don't need to divide. And the way we're going to approach these problems is we're going to draw 5 boxes for the 5 different letters we're going to pick. In the first position I could choose, I've got 5 letters to choose from. In the second position, because I've already chosen one letter, I've got 4 letters to choose from. In the third position, I've only got 3 letters to choose from, etc. And then I multiply these together using the product rule for counting, and I get 120 different arrangements of the letters in the word April. Now, I'm just going to introduce you to a function on your calculator that will do this calculation for you, and it's called the factorial function, and we would write it by factorial, which will give us 120. Okay, so let's just have a look at your calculator. So the factorial function is here, it's the x with the exclamation mark, which is just above the x to the minus 1 button. So you'll need to press the 5, and then you'll need to press the shift, and then you'll need to press that x to the minus 1 button to get your x factorial, and that will give you 5 factorial. So if you try that on your calculator now, it should tell you it's a 120. Okay, so let's just explore the factorial function a little bit more. If we were to work out 4 factorial, what the calculator is going to do is it's going to do 4 times 3 times 2 times 1. Okay, and if you do that on your calculator now, so you press 4, shift, and then factorial function, it will tell you it's 24. When we did 5 factorial, the calculator was doing 5 times 4 times 3 times 2 times 1, which was 120. If we tried 6 factorial, it would be 6 times 5 times 4 times 3 times 2 times 1. And if we try that on our calculator, shift, 6, shift, and then the factorial button, we get 720, and so on. So the factorial button takes the number and it multiplies it by every integer all the way down to 1. Now let's have a look at another example. So here we've got a volleyball team with 6 players, and they're going to start in different positions. Okay, so at the start of the game, how many different arrangements are possible for the 6 players? So we're arranging the players into positions, so order does matter, so we're not going to need to divide. That's the first thing to remember. We're going to use our boxes. I know the boxes might not seem necessary at the moment, but they will be as examples get harder, so I'm going to stick with them for the time being. In the first position, I've got 6 players to choose from. Second position, 5, then 4, 3, 2, and 1. So I would multiply these together. This is the same as doing 6 factorial, and if you pop that in your calculator, you get 720. So there's 720 ways to arrange 6 players. Right, let's look at this slightly differently now. So now we've got a volleyball team of 6 players, but we're going to choose these 6 players from a squad of 12. Okay, so first of all, how many different arrangement of these 6 players that we choose are going to be possible at the start of the game? So again, we're going to arrange the 6 players we choose, so the order is going to matter, so we're not going to divide. And I'm going to get my 6 boxes for my 6 players. So in the first position, I've got 12 players to choose from. The second position, I've now got 11 players. The third position, I've got 10, then 9, then 8, then 7. And if I multiply these together, so if you multiply those together on your calculator, we're going to get 665,280. Now we cannot use the the factorial button here because we're not multiplying all the way down to 1. Okay, so it's very important. You can only use the factorial button when you're multiplying all the way down to 1. Right, let's have a look at the second part of this question. So we've done part 1, how many different arrangements of the 6 players that I've chosen. So part 2, if I've got a squad of 12, how many different teams of 6 can be selected? Okay, so now we're just selecting teams of 6 from the 12. The order doesn't matter anymore. Let's just make sure we understand why. Let's say we chose players 1, 2, 3, 4, 5 and 6. Okay, if I then had players 1, 2, 3, 4, 6 and 5, okay, that's going to be the same team. So that's a duplicate which would need to be removed. Okay, and in order to remove the duplicates, if you think back to last lesson, when we were removing duplicates, we were always removing duplicate pairs, so we were dividing by 2. And the reason we were actually dividing by 2 is because there's 2 different ways you can arrange a pair. But now we haven't got a pair anymore, we've got 6. Okay, so we need to divide by the number of ways we can arrange 6 players, which we worked out in example 2. The number of ways to arrange 6 players is 6 factorial, which is 720. So if we pop down our 6 boxes, we know that the number of ways that we're going to get with duplicates is 12 times 11 times 10 times 9 times 8 times 7. But this time, because we need to remove duplicates, we're going to divide by the number of ways we can arrange 6 players, which means we're going to divide by 720. And if we put that in the calculator, that gives us 924 different teams of 6 players that can be chosen from a squad of 12. Okay, here's one for you to have a go at, so pause the video and try this question. So for this question, we are choosing 3 players from a squad of 8. Okay, so we're going to have 8 possible choices for the first player, 7 for the second, and then 6. So I'm going to multiply those together. Okay, but I want the number of different teams, so I've got to remove duplicates by dividing by the number of arrangements or ways to arrange 3 people, which is 3 factorial. And if we put that in our calculator, we are going to get, let's just put that in now. In fact, if we put it in our calculator, we can use the factorial button, or we could write it out as 3 times 2 times 1. So I'm just going to pop that in my calculator. And we get an answer of 56 different teams, which is hopefully what you got. Right, I want you to have a bit of practice on this. So I want you to go to the AQA Further Maths textbook scan of page of exercise 1I, starting on page 25, and I just want you to do questions 1, 2 and 14. Okay, the other questions are a different style of questions, so just question 1, 2 and 14. And then I want you to have a go at these 2 questions here. Okay, so pause the video and try that now, and I'll show you these 2 answers when you come back. So answer to A, we should have 336, and answer to B, 6,435. Right, what we're going to try doing now, hopefully if we've got time, if we've run out of time you can carry on with this next lesson, but we're going to look at some slightly different style of questions. So in the previous examples, each letter or person that we were choosing could only be chosen once, one person from a team or one letter from a word. But in some questions, a letter or a digit can be chosen more than once, and we need to know how to deal with that as well. So let's first of all look at what happens if we can choose a digit more than once. So we've got here a padlock with a 4-digit combination on it, and we want to know how many different combinations of numbers would be possible on the padlock. So if we draw our 4 boxes again, so that's for our 4 digits on the padlock. Okay, each wheel of the padlock has got the digits 0 to 9 on it. So that gives me a possible 10 digits on each wheel. So in the first position on my dial, I've got 10 digits to choose from. But the second position on my dial, I've still got 10 digits to choose from because I can still choose from 0 to 9. The third digit still got 10 digits to choose from, and the fourth digit still got 10 digits to choose from. So then using the product rule, I multiply those together and I get an answer of 10,000 possible combination of numbers on my padlock. Right, let's just have a look at a simple example now of where we're selecting numbers that can only be chosen once. And look what we might do here. So I've got the digits 3, 4, 5, 6 and 7 written on cards, and I'm going to select 4 of those cards to make a 4-digit number, but I want the number to be even. Okay, so for the number to be even, I've got to have an even number at the end. So my even numbers that I could have at the end are 4 and 6. So what I've got now, I've got 2 different possibilities. So in the first possibility, I could have a 4 at the end. And in the second possibility, I could have a 6 at the end. That's going to give me 4-digit even numbers, both of those. Okay, so I've got first possibility or second possibility. So let's look at what could be left to go in these positions here. So because I've already chosen a 4 for here, I'm now left with 4 cards to choose from. So I've got 4 to choose from this position, 3 to choose from this position, and 2 to choose from this position. So I can multiply those together, and that gives me 24 possible 4-digit numbers with a 4 at the end. And then with a 6 at the end, again, because I've chosen the 6 here, I've got 4 left for the first position, then 3, then 2. So that gives me another 24 possible numbers with a 6 at the end. So my total number of 4-digit even numbers is going to be 48. Okay. Alternatively, and this is the way we're going to look at this next lesson, if I just want to draw out my 4 boxes once, I can say, well, if it needs to be even, I need to have a 4 or a 6 in the end there. Okay, I can still work on the principle that leaves me 4 digits for the first position, 3 for the second, and 2 for the third. But because I know I can have a 4 or a 6 here, I need to multiply that possibility by 2. And if I do that, I'm still going to get the 48. So this part here is thinking about sort of my product rule for counting, and this is thinking about, well, I've got 2 different scenarios that I can consider, so I need to double that and get 48. Right, I'd like you to have just a little bit of practice of these type of questions. So I want you to again go to the AQA Further Maths textbook, exercise 1I, and try just questions 3, 4, 5 and 6 and mark them, and hopefully they should be quite quick. Just a summary then of some of the things that we've come across. We've looked at when you're arranging into specific positions, order matters and we don't divide. When we're selecting, an order doesn't matter, we do need to divide to remove duplicates. And we've also looked at when items can be chosen only once and items can be chosen more than once.